Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live. Yes, this is the new telescope. This is the 11-inch Celestron NexStar GPS. So I think we've got a pretty nice view here of the moon. I'm pretty happy with how it's performing. This is with a Blackmagic Pocket Cinema 4K, and we're shooting prime focus here at the native 2.8 meter focal length of the telescope. No Barlow lens, no focal reducer, just clean air from the telescope tube into the camera. It's not polar aligned. This is just on the fork mount, out as aligned. So field rotation will be a factor, and of course the view is currently inverted by the telescope. I can try to fix that here. Let me see, how do I do this? I think I can do this in OBS somehow. I've forgotten how to do this in OBS. I know there is a way to... here we go. Transform. Flip. Vertical. Boom. There we go. So now it's true orientation. So the large circular area in the kind of top right part of the view, that is Mare Imbrium, of course. Let's see, we've got Plato crater there. What do we got there? Is that Copernicus? I think that's Copernicus crater. Yeah, that's going to be Copernicus crater. That's right on the terminator. The crater that is almost entirely in shadow, with just the lip illuminated, just the ridge of the crater illuminated. That is a very significant crater. That's Copernicus. And to give you some sense of scale, that crater is 96 kilometers in diameter. So the mount is a NexStar 11 GPS. This is the standard mount it comes with. It's an altitude azimuth fork mount. And that's going to be ideal for a lot of what this new scope is going to be set up to do, and that is tracking launches, tracking satellites, doing that kind of work. The 8-inch LX200 will still be sort of the scope I grabbed first for doing deep space for the moment. But for solar system views, for planets, for the moon, for satellites, for rocket launches, if I need a big scope, I'm going to go for this one. Now, there may still be some rocket launches I film with smaller telescopes, depending on logistics. Obviously, this scope requires a little more time to set up and get ready. So if it's a time crunch situation where I need something that I can just throw down real quick and toss a camera on it to film a launch, I'll probably still be using the 4-inch NexStar, for example. But this 11-inch NexStar has certain benefits over even the LX200, not just in terms of its size, but in terms of the modern nature of its electronics. For one thing, it does have built-in GPS, which is always nice. It can automatically set its clock and location, but it also allows for direct drive rate control, and that allows for things like predictive tracking. So my rocket tracking software can fully utilize the predictive tracking capabilities that I've programmed into it, so that it can automatically follow the rocket based on the expected trajectory, not just based on where I'm moving the joystick or how it's following it with video. Yeah, so I turned down the music there a little bit. Sorry, it got a little bit loud there. Hopefully it's made a difference on the stream. So this is not going to be a super long stream tonight. But I do want to take this thing out and check out the moon here. This is the very first time I've ever put a camera to this telescope. I took the whole thing, well, not the whole thing, but I took the front corrector plate off earlier because while setting up the rail system on it, I've got rails on the top and bottom from ADM now installed. That allows for the attachment of accessories like guide scopes or, in my case, the viewfinder camera for tracking rockets and satellites and such. Also a rail on the bottom which has a counterweight to balance the weight of the scope, so it's not back heavy with cameras and equipment on the back end. So it's got rails on the top and bottom now, but while installing the rail on the bottom, a plate came loose because of a missing screw, and it went down underneath the mirror, which is not a great situation on a new telescope. So I took the front corrector plate off entirely to go get it, which is the first time I've ever done that on a large telescope. I have taken the corrector off the little Maxitov, the 4-inch Maxitov for the NexStar, but that's a much easier job for a variety of reasons. This was a little more complicated and a lot more scary. A lot more is riding on that operation to get that off correctly. But that job was done, got it repaired, got it put back together, got the front corrector plate back on, and earlier tonight I recollimated the scope. I was actually pleasantly surprised it didn't need very much recollimation. It held alignment pretty well, considering I took the entire corrector plate off and put it back on. Of course, it was indexed, so I put it back in the exact same orientation that it was in originally, at least as much as I could by eye. But I think the results here show that I was successful, and the image seen here you can see is very sharp. I'm sure YouTube compression is having its way with it a little bit, but on my end it looks very, very sharp. The details on the moon here are phenomenal. Definitely see an improvement over the 8-inch scope, I would say. So I hope everyone's doing well, and I want to thank you all. I want to thank everyone who has subscribed to this channel, who's even just in the chat, especially if you've ever given me a super chat, anything like that. Your money went to pay for this telescope. Just from your ad money from viewing the videos or from super chats, all of that contributed to the purchase of this telescope. So you guys made it all possible, and I want to thank every single one of you for making this possible and for improving the content that I'll be able to bring to this channel. So here it is. I mean, your money's being put to good use here, hopefully, on getting this scope up and running. And now we have this 11-inch telescope to use for viewing all kinds of stuff. Yeah, I'm quite happy with the clarity of this view. Eventually we'll put a Barlow lens on and go high magnification with it. I don't know if tonight's the perfect night for that. It's very chilly tonight, and actually we had I guess a bit of a cold front move through, possibly. I'm not sure. I haven't really been keeping tabs on the weather, but it's definitely cooler tonight than it has been recently, and that's going to play with the atmosphere a little bit. Atmospheric turbulence might be a little bit rough this week. Did some viewing on ISS with the old scope over the weekend, and the atmospheric turbulence was terrible. The seeing was absolutely terrible, and that's going to limit how much magnification you can really put to it. But we might have some fun with that in a bit. So let's move around the moon here a little bit and see what we can see. So, this is one of my favorite craters. What happened here? What's this? Oh, pop up for, No, I don't really want to install printer updates right now. Thank you very much, Windows. So, near the center of the view, just to the left of center, is one of my favorite craters on the moon. That's Clavius crater there, with the crescent of inner craters peppering it on the inside. Yeah, some of you guys are having to deal with a lot colder temperatures than any of us do here in Florida at any time. Our idea of a cold front is a joke, but nevertheless, it's really about the turbulence of the atmosphere as a result of changing weather. But it is, I'd say it's pretty clear tonight. I'm not seeing too much haze. The moon itself is bright enough that it's washing out a lot of the stars, of course, so it wouldn't necessarily be a great night for deep space viewing anyway. But this scope, just to give you a heads up on that, like, it's not going to be configured for deep space viewing anytime soon. I might play with some deep space stuff just for fun, because it's an 11-inch aperture. It's monstrous. It's a huge light bucket compared to the 8-inch scope. I mean, I've had these scopes side by side, and I'm kind of blown away by how much larger this scope actually looks in person. But nevertheless, I'd say the motors are working pretty good. The tracking's pretty smooth and very quiet. That's the other thing. The motors are very quiet on here. I have it set to track at the lunar rate. I got to remember to turn that back to sidereal before I go and do anything else. But it is currently set to track at the average lunar rate. However, I'm not 100% sure. I'm not 100% familiar with NexStar's onboard software yet. I'm much more familiar with Meade Magellan, the old Magellan computer systems that was on the old Alexandria Classic. But I believe in most cases that does not necessarily mean it's actually tracking the moon per se. That is to say, it's not necessarily tracking at the exact current lunar rate, and it's also not necessarily tracking its orbital motion, which is going to have a component in declination as well. So if you leave it sit for very long periods of time, the moon will be expected to drift slowly out of view. That's how it was with the LX200 as well. I was always setting it to the average lunar rate, the moon's average velocity in the sky, but not necessarily its current exact velocity in the sky. The moon's orbit is slightly elliptical, and so it will speed up and slow down slightly, and also it is not a 0-degree inclination orbit, so it has a component in declination, and the declination of the moon will change over time, of course. So that is not accounted for when altering the tracking rate. Do I have a filter installed? No, no filters. No filters. No focal reducer, no Barlow lens. This is just the native focal length of the telescope, which is about 2.8 meters, and exposure is currently set to 1/1000th of a second, and ISO is, what is it, 2500 ISO, which on this camera is just 1/10 of what it can do on sensitivity. Now, over here, as you can see with the different solar angle or different sun angle on the moon there, you don't see as much contrast, you don't see the craters as easily on this side of the moon right now. But just to point out that circular Maria right there, that's Mare Crisium, is Tycho viewable? That's a good question. I don't have to look and see. I don't. Tycho. I don't think so. Oh, well, no, I guess it would be. Yeah, because it would be directly above Clavius. Right. Yeah, no, it's there. Should be just on the sunlit side. We can go over there and take a look again. Okay. Now, for those who don't know, like one easy way to find Tycho is to look, or Tycho, is to look at where the rays on the moon appear to be emanating from on the southern side. So you can kind of see them towards the bottom of the view. You can see these white lines emanating from a crater, and it's just above the Clavius crater that I was pointing out earlier that has the crescent-shaped smaller craters inside of it. And above that is a prominent crater, which is, in fact, Tycho, or Tycho. And it has very prominent ejecta rays from that impact that are spread across the moon's surface that you can really see. It's a little hard to see here, but they are there, emanating from that direction. Breakdown on the optics. So the optics here, this is an 11-inch Schmidt-Cassegrain telescope, 2.8 meters focal length, f10, and it's got a carbon fiber tube, which helps not only with the weight, but also, in theory, helps with the expansion and contraction as the temperature changes over the course of the night. So you don't have as much of an issue with differences in focus from that. You still will have to deal with mirror shift from gravity, but nevertheless, that is a nice little feature of it. I mean, if for no other reason than the carry weight of it, it's really nice to have that. So, something else I want to point out. It's a nice feature of the moon that is currently well visible because of the sun angle right now. So, on the lower part of Mare Nubium, which is the dark, flat area up the top, there is a little line, looks like a hair got on the telescope. It's not, that's actually on the moon. And that's, I'm going to probably pronounce this wrong, but it's, is that right? Yeah, it's Rupes recta. And so, that would probably be, is that a collapsed lava tube or something? Oh, it's a linear fault line on the moon. So yeah, its name is Latin for straight cliff or straight wall. And so that fault line has a length of 110 kilometers and a width of 2 to 3 kilometers with a height of 240 to 300 meters. Pretty cool. Alright, thanks Final Nail. Gotta run, bro, but look forward to more from you. Appreciate it. Yeah, hoping for some good weather this weekend, because that'll be my first opportunity to potentially track the space station with this telescope. So, really looking forward to that opportunity later this weekend. Can I see the James Webb with it? Well, that's a good question. Yes, with the right camera. This camera's not really ideal for deep space work. However, it is very sensitive if you crank up the ISO, crank up the gain on the sensor all the way, and you try to reduce the frame rate as much as possible. This camera is really designed as a video camera. It's not designed to shoot stills. It just isn't. It's designed as a 4K video camera, which is, of course, perfect for doing things like this. Videoing the moon, videoing planets, videoing satellites, etc. But I have other cameras that are optimized for slower photography, still photos, long exposures, tracking, auto-guiding, all of that. But this telescope's not really configured for that, at least at the moment. Now, I could get a wedge for it and polar align it, just like I do with the LX200. That is a more difficult task. Just physically loading it up on a wedge would be taxing, to say the least. But, maybe we'll get there. In the meantime, though, you could still do long exposures, even tracking like this in altitude azimuth fashion, but you're limited in terms of how long you can run the exposures then because of field rotation. So this is not ideal for shooting beautiful pictures of galaxies with exposures that are 5 to 10 minutes long, the way that the LX200 is, just because I can easily throw the LX200 up on a wedge, polar align it, and then do tracking all night long without an issue. Because it is altitude azimuth aligned, you get field rotation, so even if you're tracking perfectly, the entire field of view will appear to rotate over the course of the night. And depending on where you're looking in the sky, that will happen faster or slower, but no matter the case, it will limit your exposures down to as short as 30 seconds in some cases. Maybe even less, depending on exactly where you're looking. And that's a real serious limitation. That is not what you want when you're doing deep space astrophotography. James Webb requires deep space astrophotography, essentially. Its magnitude currently is around 13 to 15, roughly, depending on the exact angle of its sun shield and how reflective, or how much light it's reflecting back at Earth. Do I think Webb could possibly see exhaust plumes from large ships in other systems? Well, I guess that would depend on how large they are. That's hard to speculate. I don't think any of our ships, like if we put, say, SpaceX puts a Starship up into orbit and turns on the engines, and those engines are pointed at an alien civilization's James Webb, even 10, 20 light years away, I don't think they would see anything necessarily at that scale. But, who knows? Who knows what's out there, right? There could be more exotic technologies with much larger vessels than anything we've imagined that, maybe could show up. But I'm not going to hold my breath on that. What I am hoping is that, they can study exoplanets and find evidence of not only atmospheres that would be permissible for life, but maybe even atmospheres that are changing over time because of seasonal changes caused by life forms on that planet. I mean, that would be really something to see. Can I find yeah, no. Well, actually, that's a valid question. Can I find Uranus? If it's by the moon, as you say, then the moonlight's gonna blind me from doing that. I haven't checked the current position. Let's see, how far are we from that? Yeah, it's close. It's close. We could try. I mean, it's worth a shot. Let's give it a spin. Let's see if we can find it. Now again, this camera's not configured for deep space. Uranus starts to be something that you need longer exposures and more sensitivity for. Let's see what we can do. Yeah. Oh. Oh, I pulled a cable. Well, that's fun. Why is there no signal? Oh. Huh. No signal. Why is there no signal? Arrgh. What's going on here? Come on. You crashed your camera into the mount the other day. Oh no. Come on. What is the deal here? Okay, I'm gonna try to fix the capture card here. Sorry, gang, I'm not sure what's going on there. Let me try to plug it back in and get it to reinitialize. What is the deal? I tripped on the power cable for the whole thing a little bit, but it didn't interrupt the power. It's not batteries. There's no batteries involved. But it's acting like there's nothing plugged into the thing. Oh, okay, well at least we got the no signal back. I'm gonna try it. I'm gonna try changing out the HDMI cable altogether. Not sure if that's really the problem, but it's worth a try. Yeah. Put sources on. software the capture thing came with, it keeps trying to pop up. Alright, I'm going to try removing this altogether. I'm going to try to make another video capture device. That's not what I want, guys. That was my red headlamp on the webcam. Okay, still no signal. What in the world? Okay, let me try. Okay, what is the deal? I'm going to try to unplug the capture card and just do everything over again. Now let me try to put the capture card back on. It doesn't usually give me this much trouble, but... Okay, now it's not even seeing it. What? You're not... Oh. So I don't really have it plugged in yet. Okay. Well, that's my fault. Okay, now it's plugged in. Yeah, I completely changed the HDMI cable. Maybe this one's worse? I don't know. Okay, I'll be right back. I'm going to go grab a monitor and just see if it even comes on the monitor, or is it a problem with the capture card. I'll be right back. Okay, I'm back. Alright, so I'm going to do some quick diagnostics on cables and such by throwing my external monitor on the situation and see, first of all, will it show the camera properly on an external monitor? not? Yeah, okay, we get video right away. The monitor's fine. I mean, the cable's fine. The cable's fine. It's something not right about the capture card. But my next question is whether the video pass-through on the capture card is working, because there's video pass-through option on it, which I did not have turned on, or didn't have it plugged in. So let's see if that's working. No, it is not. Okay. Oh, no, there it goes. It took it a moment, but it came up. Okay, so somehow video pass-through is working on the capture card, but it says no signal for OBS. Another USB slot. No, I haven't tried that. That's a good idea. I'm just going to delete that input source. Swap USB ports. Okay. Okay. Video capture device. No signal. What in the world, guys? What is this? This is silly. This is absolutely goofy. I don't get it. Video input is working. I don't understand what the malfunction is. I mean, it tested on another. I don't have another source to test it on. It's in the pass-through on it's even working. So it's passing video through the device. It's clearly got a signal. I don't know why it's not picking up on the computer. It makes me think it's a software side issue. I don't think it's a hardware issue. It's definitely not the camera. Plug it in again. Just try resetting the HDMI on it. Nope. I don't understand that. Yeah, restart OBS. That's my only choice, is I have to restart OBS. I think the whole computer's got to be restarted. So I'm going to have to stop the stream and restart the stream. So apologies for that. I will be right back. We'll get back on this as soon as I reboot the computer. See if that does it.